In this section we're going to use the setup defined in video 1, and we're going to acquire some I2C data packets. So the first thing I'm going to do is just move the trigger position to 10%. This will allow us to view most of the data after the trigger event, because I2C data is a single shot event. So at the moment the trigger's on stop, so I'm going to arm the trigger condition, and it's now waiting for some I2C data packets to occur. The device is now triggered, and we've acquired some I2C data, and the device has gone again to stop. So in the top display we can see some analog waveforms. So this is the channel A, and this is where we can monitor the DAC output, and we can see at this point the DAC on channel A switched. And similarly on the right hand side is the scale factors for channel B, and this is the channel B DAC output, and we can see sometime later this also switched to a lower output level. At the top of the screen we can see an overview of the I2C data, which, as we can see here in the digital display, occurred in 3 bursts. So again, we can hover the mouse over here and we can actually see the first packet, packet number 2. It was an address, and it was going to the slave address OC, which is actually the address of the DAC on the I2C bus, and this was a write to that DAC, and there was an acknowledgement byte, and again we can see the transfer times of that packet. We can then see a little later that packet 3 of the data was sent to the DAC, and packet number 4 again was data, and packet 5 was the final data packet sent to that particular address. And that concluded that particular transfer, and then there was a stop byte sent. Then there's a second transfer here, so we get a start byte, and this is the next address. This is in fact addressing the same DAC, again a write to that DAC, and then 3 more data bytes sent in fact to the channel B DAC then to switch, and here we see the 3 data bytes, and finally there's a stop byte at the end. So again, we could use cursors in this display if we want to, say, measure the time between the switching events. So we could position a cursor on when the channel A DAC switched and when the channel B DAC switched. And here we can measure the absolute time, but we can see the time between the switching edges in this particular case is 1.407 milliseconds. When you're finished with the cursor, you can just turn them off again. But we could also use them to measure, say, the baud rate of the particular data transfer. So we could zoom in and measure the clock period. So if we can use the zoom tool here and zoom right in, and then we can position the zoom box over the data required. And then we could put time cursors similarly here and measure the time of the actual clock. We take a period of the clock here, so we can see the period of this particular clock was 10 microseconds. And while we're here, interestingly, we can see when the actual DAC switched here. In fact, if I just move one of those cursors exactly onto there, we can see at this point in time the DAC had got enough information to switch to its new level, so it was using the data. But we can see actually there's a few more transactions here of the data, and these are in fact the acknowledgement bytes going back. So at this point it received the data to switch to the new level, and then the transfer was acknowledged. Again, we can return to our full display.